Καλησπέρα σε όλους και όλες. I'm very grateful to the organizing committee for inviting me. When Alexander sent me the email about Mnimi, I thought that would be somewhat challenging because, you know, at my age, I don't have a very good relationship with remembering. But those of you who have followed some of the work in space, you know that we all talk with slides. So here we go. And I thought I would start with the Milky Way because when we look at the sky at night, we see the picture that you see here, and you realize that the Milky Way, our galaxy, has anywhere between 100 and 400 billion suns. And we are one of them. And what you see, when you go out at night and you look at the sky, only the stars that in that little circle is what you really see. And that is kind of disappointing because with the naked eye, we only see a very few stars, even though, as Carl Sagan used to say, we have billions and billions of stars. Now, our solar system is moving through a gas cloud that we entered about 60,000 years ago, and we will presumably get out in another 2,000 years. And what you see in this particular picture is the heliosphere, our home. When we zero in on that, you see, first of all, that I have these different units on top and bottom called AU, which means astronomical unit. And what's one astronomical unit? Is the distance between the Earth and the Sun, naturally, about 150 million kilometers. So our solar system is about 100 astronomical units, at least in one direction, to your right. And what you see are the spacecraft that are now flying and how far they are. And you probably saw Voyager 1 and 2, and I thought I would tell you a couple of things about the Voyagers. I'm standing next to the spacecraft at the Jet Propulsion Laboratory in Pasadena, California, in the museum, and this is the first spacecraft that was constructed, the prototype, and I'm standing next to the instrument that my team and I built, called Low Energy Charged Particle. But the specifications, the weight of the spacecraft is a little less than a ton. The power, we started out at 465 watts, go down to about 232 now. The diameter of the antenna is about 3.7 meters. It's always pointed at Earth with great precision, 10 seconds of arc. And the transmitter power is about 22 watts. So these are the essentials. It was going to be a 4-year mission. And I want to show you in the next slide the trajectory of the Voyagers. In the center, you see the sun. And on your right-hand side, you see that the outer planets, Jupiter, Saturn, Uranus, and Neptune, are sort of on one side of the sun. And that happens once every 175 years. And this conjunction of the planets was so in the decade of the 70s, specifically in 77 and 78. And the idea is that if you launch a spacecraft from Earth and you go to Jupiter and use the gravity of Jupiter to sling the spacecraft to the next planet, Saturn, then you can go there very quickly. And then you do the same trick at Saturn, and you sling it to go to Uranus, and after that you go to Neptune, and so on. So it was possible to do a mission that would probably take 50 years in about 12 years. So the two Voyagers essentially investigated the outer planets in about 12 years, when you have taken many years for each one to go to one of the planets. So you also see that Voyager 1 is above the plane of the ecliptic, Voyager 2 is below the plane of the ecliptic. You see here all the planets. In 50 years, NASA, humanity, essentially investigated and flew by all the planets, most recently including Pluto in 2015, which you see down the right-hand corner. But now, you also see on the right, that's the model of the spacecraft, and what you saw earlier, yes, is the red spot on Jupiter, which is so big that 3 Earth diameters would fit in that. And also the 3 so-called Galilean satellites, Io, Europa, Ganymede, and Callisto, and they all have different colors. And they have different colors because the composition of their surface is very different. Io, for example, is a moon that has at any one time as many as 13 or 14 active volcanoes. They're not volcanoes like the Earth's that blow up and for a few days or maybe a month and then they subside. These keep going all the time. And it was the first time that we humans discovered that there is actually volcanic activity in another body in the solar system. The other, Europa, is a moon that has a sheet of ice on which is about almost 10 to 20 kilometers thick. But under that, there is a salty ocean, and it has enough water to fill all the oceans of Earth. So these were amazing things that we found. Anyway, Voyager moved on, and this is the instrument that my team built, and it was mounted on a stepper platform that rotated the instruments to look at 45 degrees every 192 seconds around, because that was important for us to make the kinds of measurements that were needed. And initially, the mission was to go to Jupiter and Saturn. In fact, we ended up, and we have taken 4 years. We have gone 250,000 steps. And now, the spacecraft is still working 46 years later, and we have gone past 8 million steps, and it's still working. So we're very happy about that, needless to say. I just wanted to show you, however, what the upshot of all this is in terms of what you see in this image, which is in the center is the sun, blue is the orbits of the planets, and now both Voyager 1 and Voyager 2 have gone outside the atmosphere of the sun, what we call the heliosphere, and into the nearby galaxy. And again, I hoped that it would start playing sound from space. But the main thing that I want to talk to you about is, of course, the golden record. It's a record, it's the first digital record that was ever made in 1976. We flew it in 77. It's on Voyager 1 and Voyager 2. The person who actually thought about that was Carl Sagan, sorry. What you saw was Carl Sagan of Cosmos fame. This was a TV series that were shown before you were born and perhaps before your parents were born. And it was seen by tens of millions of people all over the world. And what does it include? Now, I didn't have a chance to point that out, but among other things, it includes the parameters of our solar system. And on top, you can see the Sun, and then Mercury, Venus, Earth, and Mars. These underneath are the diameters. Underneath that, the second line is the distances in millions of kilometers from the distance from the Sun, the volume, and the rotation period. So the first thing we apparently, and by the way, Carl Sagan was essentially the producer and director of all of that. And the next thing that was shown was, this is, you see the Earth. In the center part, you see a picture of continental drift, how the Earth was, or the land was concentrated in Pangaea on top, and then how it evolved to today. On the right, you see a picture of the Earth, and you probably can't see that there is the percentage of the atmosphere, nitrogen, oxygen, water vapor, and so on, that is indicated. All of this, by the way, is digitally coded in the wavelength of hydrogen, which is the most common element in the universe. And of course, presumably, whoever captures the Voyagers, some tens of millions or billions of years from now, they will have a civilization that's important and advanced enough that will know all about this. So the next element is to show them about the fetus in how it grows in a human body. And on the right, you see the man and the woman. Then you see the nursing, you see the mother that is nursing a baby, and you see also the size of the family in terms of years and also weight. And then you see next, the intent was there to show the evolution of vertebrae from the fish that were in the ocean, eventually through the land animals to human beings. And the next one was some pictures of people. And you can see also some typical places on Earth, highways, a house, and so on. So these are the pictures, but that was not all that is on that record. It also had messages in every language. And I wouldn't, there are at least 55, but I thought I would read you the one in Greek. Ήτινες ποτές χαίρετε, ειρηνικός προσφύλους, ελιλήθαμεν φίλοι. This is a record that was put together by some high schoolers in northern Greece and sent to me a few years ago. Now, there are also music. This is a list of many of the pieces of music that are representative, from classical music to folk songs all over. You can see the names. We run out of time. So supposedly we had some the Prelude in E minor, violin, from Bach. Beethoven's Fifth Symphony. Who But that's not all, and I see my time is running out. Louis Armstrong, jazz, and that's all I wanted to show you. I want to tell you also that there is a movie that you can watch. I'm running out of time, but I want to leave you with this saying from Poincaré. Science is built up of facts as a house is built of stone. But an accumulation of facts is no more a science than a heap of stones in the house. I think you should all remember that when we were taught that we must remember things and not think about them. So the Voyagers' golden record was the mneme of humanity to a hypothetical extraterrestrial. And I want to leave you with a question. How would you design a golden record today to tell humanity's mneme and fly it on the interstellar probe for the next decade? Thank you.